Hey guys, in this video I'm going to go through this Leetcode 31 next permutation. So this question is to implement the next permutation, which rearrange the number into the next greater permutation of the numbers. So if such an arrangement is not possible, it must rearrange as the lowest possible number. In other words, sorted in the ascending order, and the replacement must be done in place. And we are allowed to only use a constant actual memory. So the memory is a constraint here. And let's look at this example here. 1, 2, 3. So the next permutation, so the next number that is greater than this. So I should say the smallest number that is greater than 1, 2, 3 is as a number. 123 as a number. The smallest number, let me try again. The smallest number that is greater than 123, it should be 132. Okay, so this is what it's asking. This is what I mean by next permutation. And in this case, as you can see, it's 321, and that's the biggest number possible. However, we can rearrange this number, all the individual numbers, because 3 is the biggest and also is on the leftmost position. That's why. And then second, so it's the entire number is in entire list is in the ascending order. Okay, so that's why this is the biggest number possible. And in that case, it must, as you can see in here, we must rearrange it to be the lowest possible number. That's why that's what I mean by we have to sort it in ascending order, because this is a descending order. That's the biggest number possible, and we have to reverse it becomes a in a ascending order. So let's take a look at one more example. Let me jump back. Okay, in here I have a lot more example prepared for you, and then we will walk through the algorithm together. As you can see, it's 115. So the next biggest number is, so this is 115. The next biggest number, the smallest number that's bigger than 115. After we arrange this individual number, that would be 151. Okay, so in this case, this is trivial. So yeah, we don't have to talk about it too much. This question was quite popular, as you can see. It was asked by so many companies. So let's dive into some of the example that I prepared for you. So let's say we have this number over here, and we need to find the next permutation. And the next one is gonna be easy. Like for this specific example, we only need to swap these two numbers. We swap 10 for 25, and add it to the next biggest number. And then when we are given this number, we have to swap 12 to 26, and then reverse this guy and swap these guys, or we reverse it, right? This is a descending order. However, we have to make it ascending order for this subarray or sublist. Okay, so we have to reverse it. So we are kind of getting to the algorithm now, and we talk a little bit about that, from the simplest case to a slightly more complex case. And now I think these two examples will really explain how it works. So we are given a number looks like this, a list looks like this, and we need to swap the 15 for the 31. And after we swap it, this is what it looks like after we swap it. And then we have to reverse this one. As you can see, before it was 62, 15, 12, and 3, and this number is going to be too big for us. And then we have to reverse it, and then now becomes 3, 12, 15, and 62. Okay, so We are getting there. So this is basically the algorithm, right? So we scanning through the list, and in a ascending order, sorry, in a descending order, right? So if this guy is bigger than this one, it's fine. So we move on. If the 31 is, so its next number is greater than the current number, we move on, and then move on. 62 is greater than 31, move on, and 15 is less than 62, and that is where we want to swap. So we want to swap that for what number? For the number that is greater than 15. But this, so we have multiple number. If we are given multiple numbers that's greater than 15, in this case, 62 is greater than 15, 31 is greater than 15. And what we need to do is to find the smaller number, the smallest number that's greater than 15. Let me try again. Is the smallest number on the right hand side that is greater than 15. Okay, so this is how we find the swapping candidate. And after we do the swapping, we reverse it. Okay, that's what we had before, right? 62, 15, 12, and 3, and reverse it. Reverse the sublist, become 3, 12, 15, 62. Okay, let's walk through another example. I think after we walk through this example, you have a very good idea of the algorithm, and then later on we will just implement it together. And we're given a list looks like this, and then we scan through from the back to the front, right? 3, 8 is greater than 3 is fine, 12 is greater than 8 is fine, 31 is greater than 12, which is fine, 62 greater than 31, which is fine, and 15 is less than 62. So this is where we can stop, and we can swap for the number that is bigger than 15, but the smallest number is going to be the smallest number on the right hand side that is bigger than 15. So in this case, it's going to be 31, right? Because 62 is greater than 15, 31 is greater than 15, and we only need the smaller number, which is 31. And after we do that, this is what it looks like. And then after we swap it, and then we can rearrange from the descending order to the ascending order. It looks like this because we only need the smallest, the next permutation. This is exactly why we need to reverse it. Okay, so this is basically the algorithm, and let's implement it. So we need some helper function we will go through together. After we need it, I will go through it with you. So we need a pointer, right? So, and this is exactly the first step, right? We scan it through from the back to the front. So we started with this. The first index is pretty much no comparison. There's no way to compare the one before that. So we start with the second from the last, which is why length of number minus not 1, minus 2, because we talk about index. So it's the second number from the end, and then move backward. So we move to the negative 1 index, which is not included, and then the step is minus 1 because we are going backward. And if the current number is greater than or equal to the number before that, so it's fine. So we are moving backward, right? So this will allow us to move backward. This condition means it's fine until a case where the current number is smaller than the next number, and this is where we're going to stop, right? So we break this for loop and then collect the pointer to the current index. However, if the array looks like this, is the descending order. So in this case, this exactly this example that we went through together will be the biggest number possible. So that's exactly that. And in this case, because we initialize the pointer at -1 index, which is over here, so that means this statement never get hit. And if the pointer is in -1, what we're going to do, because the requirement says that we have to reverse the whole thing, becomes the smallest number. and we can do a reverse. How can we reverse it? We starting from the 0 index to the last index possible in the list, and then reverse it. I will talk a little bit about how to implement this helper function, which is really easy. But I just want to go through the algorithm first before we go into the smaller details in the helper function. And then the next one is, again, is what we talked about before. We find the minimum number on the, so basically is the, after we get to here, we find this pointer. We need to find the minimum number in here that's greater than 15, remember? So 62 is greater than 15, 31 is greater than 15, and these two are less than 15, so that's why we don't need to consider them. And we need to find a lesser of 62 and 31, which is 31 in this case. And this is, oops, where was that? Yeah, here. This is exactly doing that, right? So I call it the mean larger, and larger means it's larger than the current position, the current number, and it's the minimum number of the larger. And I initialize it as a infinite number, which is the biggest number possible. And then I initialize the minimum larger position as the current pointer. I mean, this is random initialization. It works because after the test a few cases. So this is some initialization, and then this is the way we compare. So we look through all the possible number on the right. So from the last index to the pointer, so everything on the right of the pointer, and then we moving backward, and then we compare, right? So if that number that we're looking at is greater than the number at the pointer, so in this case it is the 15, right? If that number is greater than this, in this case 62 and 31 once again, and if that is greater than that, and also the mean larger is greater than the current number on the index, that means the mean larger is too big, and then we have to make it smaller because we need the smallest number that's greater than the number on the pointer, right? And we can update that, and also update the position of the mean larger position, and then we do a swap. And this is exactly that, right? 15 swap for 31, and that's doing the swapping. And after we do the swapping, so there's a corner case, it's saved a little bit one time. So if the pointer is at the second from the, let me try again, it's the second from the last, we don't need to do any reversing. So basically it's this case, right? So if the pointer is right here, and we just do a swap, and then that's it. We don't have to do any reversing. However, in this case, after we swap it, so we swap 15 to 31. So after we swap it, and this is where we need to do the reversing, and we can do exactly that. So we reverse the position starting from the pointer +1 to the last index. We just reverse it. Okay, so that's basically the algorithm, and let's take a look at two helper functions. One is the swap. So Python allows us to do very easily by doing this one. So we basically swap the number at index 1 for the numbers in the index 2. So we can do it simply like this. And for reversing, basically reversing is we swap. So let's look at this example right here. After we swap it, and then we want to reverse this guy, and what you need to do basically swapping again, like swapping 62 for 3, swapping 15 for 8, and then the middle one just leave it as it is. So after we swap 62 for 3, and then we get like this. After we swap 15 for 8, and then we got something like this, and this 12 just stay in the middle. So we can implement it like this. Okay, so let's run the code together. and it looks pretty efficient, right? And also the memory is pretty efficient as well. This is the main concern of this problem. And this is so much for the implementation. And for the time complexity is BO1, because in the worst case, we completely descending, we just traverse the entire list once. And even though we traversing one time in here and another time in here, so it's big O n plus big O n, and then so it's big O 2n's, but the constant is dropped, so the runtime is big O n. And for space complexity, we just need some pointer here and there, so it's big O1. We do everything in place, remember? This is so much for this solution. I hope you like it. If you do, please like this video and consider subscribing to the channel. That will be a huge encouragement to me. And thank you so much for watching. I will see you in the next video.